Hello, Algebra 2, and welcome to Lesson 3.3. We're going to talk about polynomial identities today. Our essential question is, how can you use polynomial identities to rewrite expressions efficiently? So let's go ahead and look through all of the different polynomial identities that we're going to learn about today. So the first identity that we're going to look at is sum of cubes. So this is our formula that we're going to use. And in order to use it, what we need to do is figure out what A and what B are. We're going to have to identify those two things. So if we were to look at this particular example, I could rewrite it as g to the third plus what is the cube root of 64. So we're trying to identify some cube roots in here. So it turns out that the cube root of 64 is 4. So we could rewrite this in this way, right? So 4 times 4 times 4 is 64. And h times h times h is h cubed. And that's how we would get back up in that direction. So what does that mean? That means that A is equal to G. And that B is going to be equal to 4H. And now that we know what these things are, we can plug them in. So that means that this is going to be equal to A, which is G, plus B, which is 4H, times A squared, so G squared, minus G times 4H, right? That's A times B, plus B squared. We said B was 4H, and that's squared. Let's go ahead and simplify that. Sorry, we're coming down here. So that's G plus 4H times the quantity G squared minus, let's just write that out as 4HG. And then we'll square 4H. So 4 times 4 is 16, and H times H is H squared. And there we go. We factored this using sum of cubes. Awesome. Let's look at another identity. For this one, let's look at difference of squares. So again, our first task is to identify what A and B are. So it turns out that I can rewrite this as, what's the square root of 25? It's 5. And then over here, the square root of 36 is 6. And by rewriting this in this way, I have determined that A is 5x and that B is 6y. So our next task is to plug A and B into each of these, and then we'll have it factored. So A is 5x, B is 6y. Again, I'll substitute 5x in for A minus 6y. And there we go. We factored this expression using difference of squares. Okay, let's get the next one. So this is difference of cubes. And it looks like you have the wrong one in there, but let's go ahead and do that now that it's fixed. So here we go. Again, I need to identify what is A and what is B. So in order to do that, I will write 8 in terms of its square root. So that would be 2, right? The square root of 8, cube root. Cube root of 8 is 2. So I can rewrite 8m cubed as 2m, the entire quantity cubed, minus the square root of 27 is 9. So then I've identified that A is equal to 2m and that B is equal to 9, which is going to allow me to now just plug those into this part of the equation. So A, 2m minus b, which is 9, times a squared, which is going to be 2m squared, plus a 2m times b, which is 9, plus b squared, which is 9 squared. So we'll go ahead and simplify what we have in that second set of parentheses. So 2m squared is 4m squared, because 2 times 2 is 4, and m times m is m squared. Not sure where that extra line came from. All right, 2m times 9 is going to give me 18m, and 9 squared is 81. There we go. All right, the last identity that we're going to look at is the square of a sum. So again, the same process. We're going to figure out what a is and what b is, right? And we're going to look and see how similar this is, right? A and b are just sitting right there. So a is 3x and b is 4y. So that means that we can just plug that into this part of the expression, and we can express this as, people also call it a perfect square trinomial. So here we go. So we'll plug that in, 3x. So instead of a, we'll put in the 3x squared plus 2 times a times b plus b squared. Let's go ahead and simplify that. So that's going to be 9x squared. 2 times 3x is 6x. 6x times 4y is 24xy. 4 squared is 16, and y squared is y squared. And there you have it. So today we had a look at these 4 different polynomial identities that we can use to factor or express our polynomials in a different way. Thank you all for watching today. I hope you're having a great day, and if you're not, I really hope it gets better. Take care of yourself.